All right, in this video, we're going to go over Module 10, Lesson 2, which is the zero product property and solve by factoring. All right, so this is the Florida benchmark. Given a mathematical or real-world context, write and solve one variable quadratic equations over the real number system. And it also touches on a little bit of the AR 3.6, which is given an expression or equation representing a quadratic function. Determine the vertex and the zeros and interpret them in terms of the real world context. So your warm-up for the day is going to be to factor these two quadratic polynomials. Remember, we did this previously in Module 9, so look back at your Module 9 notes if you're struggling with today's do now. All right, so if I told you that the product of two numbers is 0, and remember product means multiplication, what could you assume? So the product of any number times another number has to equal 0. Well, then that means that one of the numbers must be 0. So this is what we call the zero product property. So if A times B is equal to 0, then either A has to equal 0 or B has to equal 0. But one of those two numbers, one of those two factors, must be 0. So similarly, if we have x minus 3 as a factor and x plus 9 as another factor, and it's set equal to 0, we could assume that either x minus 3 is equal to 0, and if that's equal to 0, then what would x have to be? Or x plus 9 has to equal 0. So in order to solve this, we are going to move that constant to the other side of the equal sign by using our inverse operations. So we add 3 to both sides, or in this factor, we subtract 9 from both sides, because again, inverse opposite operations here to move that 9. And we realize that x is equal to 3 and x is equal to negative 9. So that means there are two possible solutions for x, which is 3 and negative 9. So that is what we call the zero product property, and that helps us to solve our quadratic equations. So we're going to try some different examples here. So here I have 2x multiplied by x plus 4. So here I have two factors, two things that are being multiplied together, and they're equal to 0. So I have to take that first factor, 2x, set it equal to 0. Well, if 2x is equal to 0, even if I divide by 2, guess what? X still would have to equal 0. Or there is a possibility that this factor, x plus 4, is what's giving us the 0. So if I do x plus 4 is equal to 0, subtract 4 from both sides, and x could equal negative 4. So the two possible solutions for x are 0 and negative 4. Okay, now let's go ahead and take a look at example B. So we have 2x minus 5, and we're going to set that equal to 0. So we're going to use our inverse operations to solve for x. So we add 5 to both sides. Then 2x is equal to 5. So to get rid of the 2, I can't subtract it. I have to divide it because the 2 is being multiplied to the x. So I divide both sides by 2, and x is equal to 5 over 2. Then we're going to take our second factor, x plus 11. We're going to set that equal to 0. So subtract 11 from both sides, and x is equal to negative 11. These are the two possible solutions for x. So what this means is if I took this 5 over 2 and I plugged it into this equation, then I would get 0. Similarly, if I plugged in negative 11 for my x values here, this would equal 0, meaning the whole equation would be equal to 0. All right, so you're going to try C and D on your own, and I'll come around and check when you're in class. And once we did the work, you should have gotten x minus 7, x equals negative 7, and x is equal to 10 if you did it correct. Then we have x is equal to 5/4 and x is equal to negative 1. All right, this is going to be some practice assignments or practice work for you to complete outside of the classroom. And now here we're going to talk about how to solve by factoring. So we have this quadratic polynomial or quadratic equation, 3x squared plus 5x minus 6 is equal to negative 4. And the first thing we need to do is we need to make sure that this is equal to 0, because right now it's equal to negative 4. So that means I have to move that negative 4 to the other side of the equal sign. So I'm going to add 4 to both sides, and I get 3x squared plus 5x minus 2 is equal to 0. So now that my quadratic equation is equal to 0, now I need to factor this quadratic equation. So we learned how to factor a quadratic polynomial in our previous module 9. So we're going to take this a term, 3, and our c term, negative 2, and multiply those together, and we get negative 6. So we have negative 6x squared in the top of our hourglass. And then here in the bottom of our hourglass, we have the number 5, because that's our b term, so we have a positive 5x. So what two numbers are going to multiply to give us negative 6 and add together to give us a positive 5? So we have negative 1 and 6, negative 2 or 3. Those are two possible answers. And we'll notice here that negative 1 plus 6 is equal to 5. So those are going to be the factors I'm going to use in my hourglass. And that's how I'm going to fill in my area model. So remember, my A term goes in the top left, my C term goes in the bottom right, and then that B term that I just split up is going to go in the other two boxes of my area model. Okay? So now I have to look for my greatest common factor between 3x squared and 6x. My greatest common factor is a 3x. And with negative 1x and negative 2, my greatest common factor is just going to be negative 1. Looking at this row, 3x squared and negative x, the only thing I can factor out is going to be an x. And if I have positive 6x and negative 2, I can actually factor out a positive 2. Remember, whatever the sign is here on the outside of my area model is the same sign that I factor out. Okay? So my other factor is x plus 2. So now I've factored 3x squared plus 5x minus 2. And now I am going to use my zero product property rule and set them both equal to 0 to solve. So 3x minus 1 is equal to 0. So I'm going to add 1 to both sides. So 3x is equal to 1. Divide both sides by 3, and x is equal to 1/3. So that is one possible solution for x. Now I'm going to take that x plus 2 and set it equal to 0. Subtract 2 from both sides, and x could also equal negative 2. So those are the two possible solutions for this quadratic equation. Okay, we're going to go over a couple more examples here. So we have x squared plus 8x plus 10 is equal to negative 6. So the first thing we're going to do is make sure that the equation is equal to 0. So we will add 6 to both sides. We get x squared plus 8x plus 16 is equal to 0. So I'm going to use my hourglass, and I'm going to put my a times my c in the top and my b in the bottom. And I have to find the two numbers that multiply to give me 16 and add to give me 8, which is 4 and 4. So that means that my factors are x plus 4 multiplied by x plus 4 is equal to 0. That could also be written as x plus 4 squared is equal to 0. So I only really have one factor because I have a perfect square trinomial, or a perfect square quadratic. So I only have to solve this once here. So I'm going to subtract 4 from both sides, and x is equal to negative 4. So if I plug in negative 4 for my x values here, it would equal 0. Okay, that means that that vertex is just falling right on that, the vertex of my parabola is falling on the x-axis. All right, so 4x squared plus 5x plus 3 is equal to 2. I'm going to move the 2 to the other side, so all of my terms are on one side. So I have 4x squared plus 5x plus 1 is equal to 0. I'm again going to use my hourglass to try to find my factors. So I have my a times my c in the top, 4x squared, and I have a positive 5x in the bottom. So what two numbers multiply to give me 4x squared and add together to give me a 5x? Well, that's 4 and 1. So now I'm going to show you using an area model, because remember, if my a term is greater than 1, I'm going to use an area model to find my greatest common factors of the rows and the columns. So 4x squared and a positive 4x, I can factor out a 4x. 1x and 1, I can only factor out a 1. 4x squared and 1x, I'm going to factor out an x. And 4x plus 1, I can only factor out a 1. So my other factor is x plus 1. So now that I've factored this quadratic polynomial to 4x plus 1 multiplied by x plus 1 is equal to 0, I'm then going to use my zero product property rule. So 4x plus 1 is equal to 0, subtract 1 from both sides, divide by 4, and x is equal to negative 1/4. Then I'm going to take that x plus 1, set it equal to 0, so subtract 1 from both sides, and x is equal to negative 1. So these are the two possible solutions for this quadratic equation that would make it 0. All right. So here in example G, it looks a little bit different because we have an a term of 1, we have a b term of 0 because there is no b term here, and we have a c term of negative 25. So we need to figure out what two numbers multiply to give me negative 25, but add together to give me 0. Well, if you know anything about your factors of negative 25, it's just 1 and 25 or 5 and 5. But because this is negative 25, I'm going to have negative 5 and positive 5. So my factors are x minus 5 and x plus 5. So when I take x minus 5 and set it equal to 0, add 5 to both sides, and x is equal to 5. When I take x plus 5 and set it equal to 0, subtract 5 from both sides, and I get negative 5. So my two solutions are 5 and negative 5. All right, one more example here. For h, we have an a term, we have a b term, but we don't have a c term. So when we don't have a c term, we're just going to look for our greatest common factor of the two terms we were given. So 4x squared and negative x, the greatest common factor is equal to x. So I'm going to factor out the x. So I'm going to divide both terms by x, and I get x multiplied by 4x minus 1 is equal to 0. So x could possibly equal 0. That's one option. Or I could also have 4x minus 1. I could set that equal to 0, add 1 to both sides, then divide by 4, and x could equal 1/4. All right, those are all of our examples. Here's some additional practice that you'll complete on your own. Come and ask for help in class if you need it, and then these can be completed in Canvas to see if you are right.